This lab is going to be taking a look at the electron dot structures that we talked about in lecture. And as indicated on PowerSchool, this lab is more for getting practice. This will not be required for you to do this on the next coming exam for Chapter 4, but it's good to know how to do this process, but it's also going to reinforce this concept of the 2-8-8 rule that we talked about in lecture. So let's go ahead and begin walk through this lab. And again, I'm going to be providing you with an opportunity to do this down below here after walking through the instructions. So there's going to be lots of times for you to pause, to try, to attempt it, and then to see if you've got it right. Okay, what we're going to be doing in this is we're going to be combining each of these elements with another atom, and the atom that we're going to be combining is going to be H. So to each of these, we are going to be adding a hydrogen. Now, hydrogen is element number 1. It's also a group 1, and so therefore it has one outer electron, just like this hydrogen has one outer electron. That outer electron, again, is called the valence electron. So here's the hydrogen. We're going to be combining the hydrogen with this hydrogen, with the fluorine, with the nitrogen, with the oxygen, the chlorine, and with the carbon. So what I'd like you to do is to divide this section down below into 6 sections, just like we have 6 atoms or elements that we're going to be combining them with. So this is going to be A, B, C, D, E, and F corresponding to all these over here. Okay, so I'm going to be bringing in my H first, and this hydrogen, again, is a group 1, and so it has one valence electron. There's this rule that we talked about in lecture. When forming a covalent bond, you're going to share as many as you need. Okay? Now, hydrogen is within the first period of the periodic table, and to make its shell complete, we need to have 2 electrons. So how many more electrons does this hydrogen need? It needs 1 more. So we're going to be bringing in this other hydrogen. Okay, here comes the hydrogen right here. And let's show that this hydrogen is going to have its electron as well. Let's show that it's going to be, like, for example, an X. It's still an electron, but we're just showing that it's coming from a different hydrogen. So this hydrogen has this electron, this hydrogen has this electron right there. So if this hydrogen shares its electron with this hydrogen, and this hydrogen shares the electron with this hydrogen, they both now have 2 electrons, and these electrons would be going around both of those hydrogens. So what would happen is we would form a covalent bond, and the covalent bond, we would write it, and it would look like this, H-H. Wherever we have the 2 electrons that are being shared, we show this in the form of a stick like this, like it's like a stick bond or a dash. So that's how you show this. Let's go to the next one, and then I'll get you started on the next one, and we'll pause after this. So the next one's going to be fluorine. If you take a look at fluorine, fluorine has 7 valence electrons, outer electrons, 1, 2, 3, 4, 5, 6, 7. Okay? How many does it need to be complete? It needs to have the magic number of, what is it? 8. So how many does fluorine need to be complete? It has 7, it needs 8, therefore it needs 1. So let's draw this fluorine. So this fluorine is going to be here. We'll just draw it just as it is. 1, 2, 3, 4, 5, 6. We've got the 7th one that looks like this. We're going to be bringing in our hydrogen, and we're going to show the hydrogen is going to be coming in with its electron as well. So now, the hydrogen is going to share its 1 electron with the fluorine. How many will fluorine have? It has 1, 2, 3, 4, 5, 6, 7 of its own, plus the 1 being shared. 7 plus 1 is 8. We can kind of go like this as well. We can kind of circle all those. 8 are going to be going around fluorine. Fluorine is now happy because it has a complete shell. How many will hydrogen have? It will have its electron plus the 1 that's being shared with fluorine. Remember, with covalent bonds, atoms will share the number of electrons that they need. Hydrogen needs one, fluorine needs one. So how many will hydrogen have? Hydrogen will have 2 going around it, which will make its shell complete. And the final formation will look like this. Hydrogen, and we have the dash representing the sharing of electrons, and we have the fluorine. So let's take a look at nitrogen. So if you can draw the nitrogen down below here, and you can draw their electrons, we're going to be bringing in how many hydrogens would we need? Well, we have 1, 2, 3, 4, 5 electrons. The magic number for this is going to be 8. How many does nitrogen need to share? It needs to share 3 in order to get 3. So let's bring in the hydrogens. Okay, what would it look like? Hydrogen here, hydrogen here, hydrogen here. I'm going to pause, and I'd like you to go ahead and see if you can write that. Hopefully you've finished and you've come back. We're going to draw a hydrogen over here, and this hydrogen is going to be bringing in its electron. There's going to be a second hydrogen down below here, and it's going to be bringing in its electron. There's going to be a third hydrogen bringing its electron as well. Now let's circle all the electrons that are going around the nitrogen. It has that's 5 plus the 3 that are being shared. Nitrogen has the magic number of 8 going around it. How many does this hydrogen have? It has its 1 plus the 1 that's being shared from the nitrogen. So it has the magic number of 2. This hydrogen has its 1 plus the 1 being shared. It has its magic number of 2. This hydrogen has its 1 plus the 1 being shared. It has the magic number of 2. And so we form this compound that would look like this. Okay, going over to the oxygen. You can draw the oxygen, draw the electron dots just as they are. How many valence electrons does this oxygen have? You should be saying it has 6. How many does it need to be complete? You should have said 2, because 6 plus 2 is 8, which will make the oxygen happy. So the oxygen is going to share these 2 electrons in order to get 2 electrons, and it's going to be sharing with the hydrogen. So the hydrogen is going to come over, and with its electron, the other hydrogen will come over with its electron as well. We'll draw it a little closer. How many electrons are now going around the oxygen? Just like before, it has 1, 2, 3, 4, 5, 6 of its own, plus 2 that are being shared. This hydrogen has 2 going around. This hydrogen has 2 going around. So the hydrogen will always have 2 to be complete, and the other elements will have 8 to be complete. What have we just formed here? HOH, also called H2O. We've just formed water. Going on to the next one, if you can draw the chlorine with the electron dots just as they're drawn. How many does chlorine have in its valence shell? You should be saying 7. How many does it need? It needs 1 more. So it needs to share 1 to get 1. If you can try to draw this and what it would look like. Hopefully you've drawn this and you're coming back, and you should have drawn an H over here, bringing in its 1 electron to share. So the H brings in the 1 electron to share. Now chlorine has 8 electrons around it, and it's going to be happy. The hydrogen donated its 1, and it's also getting 1 as well, so it has the magic number of 2. So we form this. This is also called hydrochloric acid. Now the last one, I would like you to try to do by yourself. What's the final compound going to look like? Ask yourself how many electrons are in the outer shell. How many does it need? How many hydrogens are we going to bring in? I'd like you to pause and see if you can fill this out. Hopefully you've come back and completed it. Here's the carbon. The carbon has 4 electrons. It needs 8 to be happy, and so we need to bring in 4 of the hydrogens. How many electrons are now going around the carbon? 4 of its own, plus the 4 that are being shared. It now has 8 electrons going around. Each hydrogen should have 2 electrons going around itself. What's the final compound going to look like? Essential carbon. And if you remember, every 2 electrons is going to represent a covalent bond.